children. இப்போ இன்னிலேருந்து what we thought was, instead of going with 11th syllabus, since you are having a separate session for 11th and separate session for 12th, so in this 12th session we'll only concentrate on the 12th portions. Okay, the 11th portions will be covered in the 11th corner and the session. Okay, so if somebody wants to recap, somebody who is new student, you have to practice problems from 11th also, because the IIT JEE will have problems from 11th portion and 12th portion. Okay, so many questions are have seen coming from 11th portion. Okay, so you can say like 40-60%. So out of 30 questions are there in maths, so you can expect about 10-12 questions from the 11th portion itself. Things like permutations, combinations, sequence and series, binomial theorem. They're not common. They're asking many questions. Probability, trigonometry, all the functions and relations, sets, everything. So you have to practice all those also. They are very easy since you have already learned and you have more time to practice. So you can, by practicing those, you can assure yourself at least some 10 questions. Okay, and in the 12th class we are going to focus only on the 12th syllabus. Okay, so so இன்னைக்கு அதனால what I thought was, the first chapter from your book, I saw that it is matrices and determinants, application of matrices and determinants. I thought that chapter would have been covered, completed for all of you. So am I correct?
Yes sir.
சார் எங்க ஸ்கூல்ல அது பாதி தான் சார் நடத்திருக்காங்க.
Okay,
மிஸ் 1 week holiday சார்.
Okay, what about Trino? Okay, so வேற சுந்தரேசன் வேற என்ன நடத்துறாங்க உங்க ஸ்கூல்ல? இந்த சாப்டர் விட்டுட்டு வேற ஏதாவது நடத்திட்டு இருக்காங்களா, இல்ல இவ்வளவு ஸ்லோவா போயிட்டு இருக்காங்களா ஃபர்ஸ்ட் சாப்டர்லயே?
சார் இந்த சாப்டர் தான் சார். மிஸ் ஃபர்ஸ்ட் 1 week ஏதோ ஃபங்க்ஷன் லீவ் போட்டாங்க சார்.
ஓ, ஓகே ஓகே ஓகே
சார் எங்களுக்கும் 1.5 வரைக்கும் தான் சார் நடத்திருக்காங்க.
ஃபுல்லா நடத்தல?
எஸ் சார், ஃபுல்லா நடத்தல சார்.
ஓ, ஓகே ஓகே ஓகே. ஸோ அப்படின்னா see, the matrices and determinantsல is anybody from CBSE out of the 3? Nobody, right? All are from state board. Okay, so state board the syllabus is pretty good as far as matrices and determinants are concerned. There are many chapters are covered, many aspects are covered, many concepts. Whereas in CBSE, the syllabus is very weak. Okay, so if there is any CBSE student, they have to look at the state board book, at least for this particular chapter, matrices and determinants. So problems are coming mostly from those topics, like the theorems on determinants, and there are various theorems on inverting a matrix, then adjoint, and relating the determinant, adjoint, inverse, and then solution of simultaneous equations, checking for consistency. There are different methods for that. So those, and including rank of a matrix, all those, that is where most of the problems are coming. Okay, so what I will do anyway, we have to start. We'll go parallelly, since your school anyway, your your school is covering this chapter. So if some problems, if you do in this, even if it is new to you, so you can learn it. But like I am repeating, I keep telling in every class that you have to read the book and you have to read the examples. So look at the examples, try to solve the problems in your own book. If you are able to do that for state board syllabus, you can easily crack the problems in IIT JEE. Particularly for matrices and determinants, since your chapter is very advanced, your content, the questions are easier. So only straightforward questions. Now I see that they are not very difficult also. So please work accordingly. So what I will do, I will start with a few problems and let me see how much you have been taught. So we'll also parallelly do that. A few problems only I will do, and you can go back, go home, and then again read the concepts. And I will send you some practice problems also later, so you can practice them. And if there is more time, I think I had given exercises on binomial theorem and sequences and series. So we had worked out a lot of problems in the class, and then I had asked you to practice. So I've seen that Sundaresan, you've solved quite a few of them, but some of them you are still working on, I think, right? So
Yes, sir.
yeah, anything where you have already tried and you're having a doubt, so we can discuss that also, okay, today. What about Chino? Did you get a chance to look at those problems? Chino, are you there? I'm not hearing anything from Chino. What about Sai Priya? Have you looked at the problem that we had discussed and some exercises that we had given? Did you have a chance to look at those, Sai Priya?
No sir, நான் பார்க்கல sir.
Okay. So because the IITJ you're going to do advanced problems, you should come prepared, okay? And then it is not enough to just hear. After hearing whatever I say, you have to go and practice some problems. Otherwise, you're not going to be able to solve the problems here. Okay? This is very, very important. Hi, Santana Mariraj. Good evening.
Good evening, sir.
Yeah. So for you, have they completed this application of this matrices and determinants, that chapter? How far have they come in your school?
Sir?
What are your maths class should have started, right? They should be covering
Yes,
matrices and determinants, right? That is the
sir,
first
finished
chapter.
it, sir.
What?
Matrix and determinant, we have finished it, sir.
Okay.
We started continuity and differentiability, sir.
You are from state board or
CBC, sir.
CBSE? Oh, I was telling about CBSE. I don't know if you were there at that time. CBSE, the syllabus is very weak as far as matrices and determinants are concerned. So there are so many things are missing. So you have to go by state board book, Santana Mariraj. Okay.
Okay,
Or
sir.
you can download it, from the internet. It is available. Okay. So and read that. There is much more in the state board book compared to what is there in your CBSE. So you have to read all that and practice them. Okay, the questions are coming
sir.
only from those portions. Okay, so not from the simple portions that are given in your CBSE book. Okay, so I will do some problems in applications of matrices and determinants today. Okay, so you can see what kind of problems are coming in IIT. Okay, so let me start. After that, Santana Mariraj, did you have a chance to look at the problems that we additional problems that I had given, no, on sequences and series, binomial theorem and all?
Yes, sir, I was solved, sir.
நீங்க போட்டு பாத்தீங்களா?
Yes, sir, I was solved.
You solved sequences and series also?
Yes, sir.
Okay, very good, very good. So any ஏதாவது போட முடியாதவங்க இப்போ ட்ரை பண்ணிட்டு டவுட் இருந்ததுன்னா அதையும் நம்ம டிஸ்கஸ் பண்ண ட்ரை பண்ணுவோம். Since உங்களுக்கு அந்த matrices இன்னும் கம்ப்ளீட்டா கவர் பண்ணலங்கிறதுனால I will not spend much time. Okay, only 1 or 2 problems பண்ணிட்டு, so we'll look at whatever is covered for you, like sequences and series and binomial theorem. Okay, so we'll keep it like that for today. Okay. So I think these, I've not listed everything from the book. I just tried to write some important points here. Matrix theorems, properties of determinants, இதெல்லாம். So you all basically know what is a matrix and what is a determinant. Determinant is a numerical representation of a matrix. Okay. So and the rules are different for matrix and a determinant. Okay. So you have to be careful in solving these problems. And then you have in your book you have the method to what is a minor, what are what is a cofactor, and how do you invert a matrix, and how do you check the consistency of equations. So all those things you have to be very comfortable with those concepts. Okay. So if as far as determinant is concerned, it is some of the simple things. Determinant of A is determinant of A transpose. Determinant of AB is determinant A into determinant B. So consequently, determinant of A power n equal to determinant of A, n times. That means determinant of A whole to the power of n. And this is very important. Lambda A, determinant of lambda A is not lambda determinant A. It is lambda to the power of n a determinant of A, where n is the order of the matrix. So this determinant, these are all applicable only for square matrices. Okay, so n, that is why n is the order of the matrix. There is no m into n, just this n. Okay. And as far as other theorems are concerned, so the determinant of these are properties of determinants. Okay, so determinant of a matrix remains unaltered if its rows are changed into columns and columns are changed into rows. That is A determinant of A equal to determinant of A transposed. Then if any two rows columns of a determinant are interchanged, then the determinant changes in sign, but its absolute value remains unaltered. So so you can interchange two rows. Then if there are when you do that, the value of the determinant becomes negative. Okay, so previously if it was x, then it will become minus x. Then property 3, if there are
Sir.
yeah.
சரி, ஒரு மேட்ரிக்ஸ்ல வந்து ஸ்கொயர் மேட்ரிக்ஸ்ல ஏபிசி அப்படின்னு 3 ரோ இருக்குன்னா அதை வந்து பிஏசி அப்படின்னு மாத்தினா வந்து சைன் ரிமைன்ஸ், இது சைன் சேஞ்சு பட் வேல்யூ அன்ஆல்டர்ட். அதானே சார்?
That is right. That is right. Exactly. Okay. If there is one change, the sign becomes, plus one. It becomes negative. So if you make two such changes, it becomes again minus into minus, which is plus. So that is what is the next property. If there are n interchanges of rows of a matrix or columns can be interchanged with another column, or row can be interchanged with another row. If you do that, then the determinant of the resulting matrix is minus 1 to the power of n into determinant of A. Okay. So if two rows of a matrix are identical, then its determinant is 0. Okay, if you are able to bring two rows to identical. If a row of a matrix is a scalar multiple of another row, then its determinant is 0, because that scalar can be taken out. Okay, that is the next property. You can see that the scalar can be taken out, then the two rows will become identical, and hence according to property 4, the determinant value will become 0. Another important property is if each element in a row is multiplied by a scalar, then the determinant is multiplied by the same scalar k. Okay. If each element in a row in one row, you please note this. If each element in one row of a matrix is multiplied by a scalar, then the determinant value gets multiplied by k. Okay. If you multiply the whole matrix by the scalar k, so that is what is scalar multiplication of matrix. When we do a scalar multiplication of a matrix, all the rows we multiply by k. When we do that, then the determinant gets multiplied by lambda to the power of n. Okay, if there are three, it's a 3 by 3 matrix, then because in all the 3 rows you are multiplying by lambda, so you can take out lambda 3 times. That is why it gets multiplied by lambda cube. These are very important. We carelessly we might put determinant of lambda a equal to lambda determinant a. So we should not, that those kind of mistakes you should not make. We will be very careful about determinants. So it will be lambda, like I think I already showed you that, the lambda to the power of n into determinant of a. So if then property 7, if each element of a row of a determinant is expressed as sum of 2 or more terms, then the whole determinant is expressed as sum of 2 or more determinants. So if every element we can break it into 2 elements, okay, so then the determinant itself can be broken down into 2 determinants. And then if to each element of a row the equi multiple of the corresponding entries of 1 or more rows are added or subtracted, then the value of the determinant remains unchanged. Okay. So these are some of the basic rules about determinants. These are used in elementary transformations in solving simultaneous equations, and the methods like Gaussian method mainly uses this approach, the elementary transformations. Okay. Next, there are some other points I wanted to mention. So we must know what is a minor, cofactor, and adjoint. So these are the basic components of a matrix. Okay, so the minor is a matrix formed by removing a particular row and a column. If you take A, I, J, you remove that ith row and jth column, whatever remains is the minor of that particular element. Cofactor is a signed minor. It's -1 to the power of m plus n into minor. Adjoint is you form the matrix of cofactors and transpose it. So it is basically transpose of matrix of cofactors. That is what is your adjoint. Okay. So there are various theorems on using these problems. I'm showing all this because you should be comfortable with this, and problems are going to be mostly on these transformations, these kind of formulas. So A into adjoint of A equal to adjoint of A into A equal to determinant of A into in. Okay. So all these proofs, explanations are there in your book. If you don't, if you are CBSE, please go and read the state board book. Okay. So A inverse equal to 1 by determinant A into adjoint of A. So determinant of A inverse is 1 by determinant of A. So then A transpose, inverse of A transpose is transpose of A inverse. So lambda A whole inverse is 1 by lambda into A inverse. So AB whole inverse is B inverse into A inverse. A inverse is A. So adjoint A, inverse of adjoint A is adjoint of A inverse, which is 1 by determinant A into A. Okay. Okay. These are all very important. Determinant of adjoint A is determinant A to the power of n minus 1. Then adjoint of adjoint A is determinant of A to the power of n minus 2 into A. Adjoint of lambda A is lambda to the power of n minus 1 into Aj. So determinant of adjoint A is determinant A to the power of n minus 1 whole square. So it goes on like this. Adjoint will be determinant A into n to the n minus 1 to the power of 3 and so on. So adj transpose is adj A transpose. Okay. So I only given some of them, not all. Okay, just to show that these are the kind of formulas that we'll be using in problems. IIT problems are mostly going to be based on these. Okay, so now let's go to some problems. One problem. So based on whatever we have discussed so far, so how comfortable are you on these things? Whatever I showed you, these kind of, this is what is, the problems are going to be based on this. Sundaresan, இதெல்லாம் உங்களுக்கு நடத்திருக்காங்களா? ஓரளவு கம்ஃபர்டபிளா இருக்கா?
சார் இதுல ஒரு பாதிக்கு மேல தெரியும் சார்.
பாதிக்கு தெரியும். Okay, okay. So anyway, I will show some IIT problems so that you can go practice and focus, goes like that. Okay. So let us try to do this problem. This is from last JEE, April JEE. Okay. So matrix A is a 2 by 2 matrix and A square equal to I. Okay. No element of the matrix is 0 and sum of the diagonal elements is A and determinant of A is equal to B. Then find the value of 3A square plus B square. Basically find the value of A and B. Okay, so then you can find out the value of 3A square plus B square. I will tell the initial step. Okay, so then you try to solve it. Okay, so it's given that matrix A is a 2 by 2 matrix. So since the letters A, B are used, I'm going to use, let us say it is P, Q, or S. It is very easy actually. But once you start, it will become very easy. So let us assume that the matrix is P, Q, R, S. This is only a 2 by 2 matrix, right? And it is given that A square equal to I. Okay, so this is your A. Okay, so now find out A square and equate to I. Okay, so then you will get some equations. Okay,
Sir, one doubt.
Yeah.
So 3A square, sir.
Ama. Value of 3A square plus B square.
Sir, A கொடுக்கவே இல்லல்ல sir.
இருக்கேமா. Sum of diagonal elements is A.
Okay. Okay, sir. Okay.
Okay. So now it is given that A square equal to I. So assume that A equal to PQRS and find out A square. Okay. And it's also given that sum of diagonal elements is A. So what you can do from that? So the sum of diagonal elements is P plus S or Q plus R. So that is equal to A. Okay. So from A square equal to I, so that is the main thing. So you get some equations. That is the basis for solving this problem. So what is A square? Work it out and tell me. So what will be the first element?
P square plus QR.
P square plus QR. And what is the second element?
PQ plus QS.
Very good. And this third element?
PR plus SP.
PR plus SR, right?
Yes, sir. Yes, sir.
And this element? RS into QS. RQ plus the QR plus S square. This into this. QR plus S square. It is equal to I. So this is your equation. So from this, what can you say?
E square plus QR equal to 1.
Yes.
P equal to minus S.
So PQ plus QS equal to 0. PR plus SR equal to 0. QR plus S square equal to 1. Okay. So let us look at this. This is telling that Q into P plus S equal to 0. So it is given that none of the elements are zeros. That means Q is not 0. So what does it tell us? Right? So what are the what is P plus S? Sum of the diagonal elements, right? So look at this also. R into P plus S equal to 0. Again, R is not 0, therefore P plus S equal to 0. So they are given that sum of the diagonal elements is A, right? And we have got their value for sum of the diagonal elements. So from this, what we can conclude? Sum of the diagonal elements is A, therefore A equal to 0. Okay. So then what else is given? Determinant of A is B. So then what is the value of B? We have to find out now. Okay. A square equal to I. Let's look at it. Then determinant of A square equal to, what is determinant of I? One, right? So now we just now saw a rule. Determinant of A square is determinant of A the whole square. And what is B? Determinant of A is your B. So from this, we can straight away deduce that B square equal to 1 and A equal to 0. So it's so easy, you know, it looked so difficult in the beginning. But actually, just within 1 or 2 steps, you see that, you know, A equal to 0, B square equal to 1. So what is the value of 3? What is asking? 3A square plus B square. Will be?
So 1.
Yes. That's all. Okay. Okay. So let's look at one more problem. I am not able to prepare the problem and send it because this matrix, we cannot type it out. So I have to handwrite it. So that is why I could not type it beforehand. So, okay, let me go to the next problem. Let's see. The A equal to, this is also from the last IIT, okay? 2 1 0 1 2 minus 1 0 1 2. And then determinant of adjoint of adjoint of adjoint of A is 16 to the power of n, then find n. This is your question. Okay. Any idea how we can do this?
So adjoint of adjoint of adjoint of A is equal to A, sir.
No.
So
It's not
is
equal to A.
adjoint of A.
No, it's not equal to adjoint of A. We have to look at the formula for this determinant of adjoint of adjoint of adjoint. Okay, so you see this formula. Now I'll take you to that formula. Determinant of adjoint. What is this? This is the formula. Determinant of adj equal to determinant of A to the power of n minus 1. So just apply this formula. That's all you have to do. Adj is, can be derived from the first formula. Okay. Write down this formula, this rule, okay, or theorem. Determinant of adj equal to determinant A to the power of n minus 1. Because I'm going to close it and move to the problem page. Determinant of adj equal to determinant of A to the power of n minus 1. So in this case, what is the value of n? It's 3, right? So we can simply say determinant of A square. Now what is determinant of adj of adj? Okay.
Sir, mod A to the power n minus 1.
Yes, correct. So mod can determinant, okay? Determinant of adj to the power of n minus 1. Because that is our rule, right? Adj, either nama A nu vechipom. Instead of A, you put adj in the previous formula. Determinant of adj is determinant A to the power of n minus 1. Determinant of adj will be determinant of adj to the power of n minus 1, which is equal to, this is determinant of A to the power of n minus 1, again to the power of n minus 1. That will become determinant A to the power of n minus 1 whole square. A simple expansion of the same rule. Similarly, you go on like that. Add 3 வாட்டி கேட்டிருக்காங்க அவ்வளவுதான். What will this be? Determinant of A to the power of n minus 1 cube. That's all. So this is a formula that you need to know. Adj A is determinant A to the power of n minus 1 cube. Since A is given, so you can easily determine determinant of A. And here n minus 1 is 2, right? So what is 2 cube? 2 cube is 8, right? So it's going to be whatever we want, that is going to be determinant of A to the power of 8. And now let's determine the value of determinant of A. That is
8, sir.
Huh?
8, sir.
You got it as 8? Very good.
Yes, sir.
Be 8. Let me just check that. So did everybody get the same thing?
Sir,
Correct.
7.
The 8 is correct. Okay, check that. It's 8 only. So you can take some time, check it out, all of you. Equal to, so determinant of a to the power of 8, that means 8 to the power of 8. So problem doesn't stop here. They are giving that this is equal to 16 to the power of n. So find out the value of n. Solve this. This should be very easy for you. 8 to the power of 8 equal to 16 to the power of n. So how can I solve this? Anybody has started?
Sir, 2 ஓட பவரா எல்லாத்தையும் கன்வெர்ட் பண்ணுங்க
Sir,
சார்.
2 power.
Correct.
Sir,
That
2
is the
power
correct
3 the whole power 8. 2
Yes.
power 24.
2 to the power of 4 to the power of n. 2 to the power of 24 equal to 2 to the power of 4n. And
N is equal to 6.
That's it. Okay. Okay, so there are more problems like this. The many problems. So you can see what kind of problems you are going to get. Okay. So easy once you know these concepts, it will be very easy. Okay. So now we will do one more problem. So adukku dhaan namakku time irukum. One more problem on the system of equations. Okay. So there is a system of equations, or we call it simultaneous equations, right? X plus y plus z equal to 6. X plus 2y plus lambda is z. Sorry, alpha is z equal to 5. And x plus 2y plus 6z equal to beta. So the options are, they are given various options. Infinitely many solution, for alpha equal to 6 and beta equal to 3. Second option, infinitely many solutions for alpha equal to 6, beta equal to 5. Unique solution for alpha equal to 6, beta equal to 5. No solution for alpha equal to 6, beta equal to 5. Okay. So there is a method called the Gaussian elimination method. So we are going to use it to solve this problem. நடத்திருக்காங்களா உங்களுக்கு? I don't know if they would have come this far. Gaussian elimination method.
So with the help of matrices, sir, or
With the help
by
of matrices
using algebraic, sir?
With the help of matrices only. But algebraically
Yes.
also we can do. Okay.
சார்
But how will you determine what is the rule for, whether the system has got infinitely many solutions or unique solution or no solution? How will you determine?
Sir, if adjoint of A, so adjoint of A into B is not equal to 0 matrix means this is inconsistent, sir. If
See,
adjoint of A into B is equal to 0 matrix means it has either infinitely many solution or no solution, sir.
not exactly like that. It's not adjoint. So you have to look at the value of the determinant. So you have to first of all take A is your determinant. What is your matrix A? 1,
1 1 1
1, 1, 1,
1 2
2.
1, 2, 6, sir.
Okay. This is what we call as matrix A, and matrix X we call as X, Y, Z. And matrix B is your right hand side, which is
5 beta
6, no?
5 beta
6, 5 beta. Okay. So we will go according to the method. We'll try to solve the problem. And we will see how to conclude, make the conclusion in the end. Okay? Use Gaussian elimination method. Gaussian elimination method, what you do, no? You create an augmented matrix. You put this matrix A. It is like, the way we solve simultaneous equations. It's not, again, some fancy names, but it is very much like how do we solve the simultaneous equations. Okay. So create an augmented matrix like this. Put A and B together. Okay. So then you do elementary transformations, okay, to make this a diagonal matrix. Okay, so these elements we make it as 0. The ones below the diagonal we make it as, try to make it as 0. So then it becomes a diagonal matrix. So then it becomes a solution. From there we can see. So I'll tell you when let's come to that. Then we'll look at the rule for that. So how can we make this as 0 and this as 0? This is your R1, R2, R3. So what transformation you will do?
Sir, R2 minus R1, sir.
Very good. R2 change to R2 minus R1, and R3 minus R. When you do these transformation, what you will get? R1 doesn't change. R2, 1 minus 1, 0, 2 minus 1.
0, 1.
R2 minus R1, right? This is all.
Sir, 1.
Alpha minus 1, R2 minus R1, no. And this will be, again here also you have to do the same transformation. This is 5 minus 6.
Sir, 2 minus 1 is 1 then it.
Yes, sir.
Mama. 1, correct. 2 minus 1. 1 minus 1 is 0, 2 minus 1 is 1, alpha minus 1. Okay. So this one is 0. Again 2 minus 1, 6 minus 1.
5.
This is beta minus 6.
6.
Okay. So your first transformation. 1, 1, 1, 0, 1, alpha minus 1, 0, 1, 5, beta minus 6. Next, you try to make this 0. Okay. So how can you make this 0? R3.
Yes, R2, sir.
Again, in this problem, it's all very easy actually. Okay, R3 minus R2. This doesn't change. R2 also doesn't change. So R3, 0 minus 1, this is 0, this is 0, and this is 5 minus alpha minus 1, means 4 minus alpha. Sorry, 6, right? 5 minus alpha minus 1. And this is beta minus 6. Beta minus 6 plus 1, right? Minus of minus 1. So that means beta minus 5. Beta again, beta minus 6 minus 1. So that means beta minus 6 plus 1. Beta minus 5. So now you can see that if you put alpha equal to so what are the values given? First one is alpha equal to 6 and beta equal to 3. So you put alpha equal to 6, what do you get? Put alpha equal to 6.
6 minus 6, 0, sir.
1. 6 minus 1 is 5 here. 6 minus 6, 0. This is 6 minus 1. And then beta?
Minus 5, sir.
1 minute. We have to put alpha equal to 6 and beta equal to 3. Okay, both. So 3 minus 5 is minus 2. Okay. Now what you should do is find out the rank of the matrix, transformed matrix A, and the rank of the augmented matrix. This whole thing we call as augmented matrix, and this alone we call as matrix A. Okay. So what is rank of A? Since this is all 0,
3,
we cannot. So it is. But you can find a sub matrix or a minor which is non-zero, right? 5 into 1, 1 into 1. It is not vanishing. Therefore, its rank is 2. Whereas rank of augmented matrix that is 3, because this whole thing is not going to vanish, because here there is a value. Okay, so this is not vanishing. So therefore, this rank of augmented matrix is 3. If the rank of matrix and the rank of augmented matrix, they are coming differently, then our conclusion will be this is inconsistent. Okay. Next, what they are given? Put alpha equal to 6 and beta equal to 5. Alpha we are not changing, therefore that will remain the same. Beta 6 minus 1. This is beta minus 5. So if you put beta equal to 5, this is going to become 0. From here, rank of A is 2, and rank of augmented matrix is
2,
also 2, because this is also vanishing. Since these two are matching, this solution, this has got a consistent solution. Okay. This means this is a consistent solution. Rank should be equal. Okay. Next, what you should say is, if rank is equal to number of variables, means it is unique solution. Rank not equal to or less than number of variables, as in this case, this means this is infinitely many solutions. Okay. So from this we can conclude that so what are the options given? Infinitely many solutions for alpha equal to 6, beta equal to 3, that is not correct. For alpha equal to 6, beta equal to 5, it has got infinitely many solutions. So unique solution for alpha equal to 6, beta equal to 5 is also not correct. No solution, that is also not correct. Okay. So the correct option is option 2. Okay. So there are many other problems similar to this, but I'm going to send some of them to you for practice. Okay. But since your class is also not completed, I hope this was useful to you, since the same is being covered in your class also. So please go read the book, look at the examples, look at your some sample problems, and then I'll send some problems to you practice those. Okay. So with that, let's close this matrices, and I want to spend some time on the binomial theorem and the sequences and series. So whoever has done the problems and have questions on any particular problem, we can look at that. Sudarshan, yeah, Sudarshan. Go ahead, Sudarshan. Which problem? Sudarshan? Sorry, it's not Sudarshan. I'm sorry. Sundaresan, hi.
Sir, sorry.
Yeah, you are on mute, is it?
Sir, mic on it, sir.
Yeah. Now I am able to hear. Okay, Sundaresan,
Okay.
let's.
Sir, sorry, sir. Mistake, sir.
So any problem that you have tried to solve and you have stopped, you're not able to solve. Let's look at that. Let's look at binomial theorem, which any problem you want to see now. Let me put up the binomial theorem now. Let me put up the binomial theorem questions. Are you able to see the binomial theorem problems now? So I think we solved problem number 1, 2, 3, 4, 5 in the class itself. Sixth problem, could you solve it? Sundaresan, you are on mute.
Sir, no, sir.
Sixth problem you are not able to solve. Okay. Sai Priya, so I hope you are also following. So here we are in the last couple of classes, before two classes, I think we discussed this binomial theorem, and we worked out some problems, and I gave some practice problems. This is one of the practice problems. Okay. So this problem maybe we can look at now. So how far did you go, Sundaresan? எவ்வளவு ஸ்டெப்ஸ் வரலையும் முடிஞ்சது? என்ன எங்க ஸ்டக் ஆச்சுன்னு சொல்ல முடியுமா?
ஆக்சுவலி அதுல ஒரு ஸ்டெப்புக்கு அப்புறம் எனக்கு எல்லாமே வந்து ரிப்பீட் ஆகிட்டே இருக்கு சார்.
அப்படியா? I am not able to insert. Okay, so I will simply add a page. That will be better. This stupid thing, it's not working for me. I'm typing something, but it is not coming. Okay. The expansion is 1 plus x whole to the power of n, right? N plus 2. 1 plus x whole to the power of n plus 2. That the ratio of 3 consecutive terms is 1:3:5. Then find the sum of the consecutive terms. 1:3:5. Okay, so let us write the expansion for this. 1 plus x whole to the power of n plus 2 is 1 plus n plus 2 c1 x power 1 So let us take the 3 consecutive terms as n plus 2 c r minus 1 n plus 2 c r n plus 2 c r plus 1. Okay, so this is your rth term, r plus 1th term, r plus 2th term. So that doesn't matter. These are the 3 terms that we are taking: n plus 2 c r minus 1, n plus 2 c r, n plus 2 c r plus 1. Okay, so if we take these, the ratio is given as 1:3:5. That means n plus 2 c r minus 1 is to n plus 2 c r.
சார் இதுல எக்ஸ் டேர்ம்ஸ்லாம் வராதா சார்?
X terms varadima. It's only the coefficient, right? The coefficient of the 3 consecutive terms. It's not including the x term. Okay. You didn't do like this. You tried to put x also in this, is it? Okay. So with this, will you be able to proceed? Try the next step. So what will this be? n plus 2 C r minus 1 is n plus 2 minus r plus 1. So that is n minus r plus 3. This is n plus 2 minus r.
சார் கொஸ்டின்ல கோஎஃபிஷியன்ட்ன்ற வேர்டே யூஸ் ஆகல சார்.
That must be a mistake. Okay, the binomial theorem is only about coefficient. If x is also included, you don't know the value of x, right? So you cannot find out any ratio like this.
Okay, sir.
So if you miss that part, I think you can correct it, and if you do it, probably you will be able to do it. Okay. But anyway, still I'm doing it. So this ratio is so I'm dividing, okay? So this goes. So always, these two goes and you get an r here. These two goes and you get an n minus r plus 3. This is actually not very difficult actually. R by n minus r plus 3 equal to 1 by 3. That means 3r equal to n minus r plus 3. That is n minus 4r plus 3 equal to 0. Or n minus 4r equal to minus 3. This is your equation number 1. Same way you do the second ratio. Okay, so you'll go to get another equation like this, n and r. Then you solve it and you get n and r. And what is the question?
So the second equation would be 5r plus 5 equal to 3 of n plus 2 minus r.
What is that? Did you get an equation like this? N minus 4r equal to minus 3. Similar
Yes,
to that. What is the other one?
5r plus 5 equal to sir ratio 3 by 5 la sir.
1:2, yeah, 3 by 5.
Sir 3 of n plus 2 minus r. Full bracket sir. N plus 2 minus r.
So that means 5r plus 5 equal to 3n plus 6 minus 3r. So bring all n and r on one side and numbers on the other side, no? So that means I'm bringing a number on the left side now. Plus 5 minus 6 equal to 3n minus 3r minus 5r. So now I bring this. This is, what did I do? This is 3n minus 8r now. 3n minus 8r equal to minus 1. This is your second equation. Correct, Susan Sundaresan? So whatever you said, it can be transformed in this way, right? 3n minus 8r equal to minus 1. So you now solve this. So the first one you multiply by 2, you get 2n minus 8r equal to minus 6. You subtract, you get n equal to 5. Okay. So substitute n equal to 5 in the one of the equations, you get 3n minus 8r equal to minus 1. So 8r equal to 16 or r equal to 2. So n equal to 5 and r equal to 2 is what you are getting. So what is the question? Sum of the consecutive terms is. Okay. So what are the terms we have taken? So these you can simply take n plus 2 cr minus 1, n plus 2 cr, n plus 2 cr plus 1. So whatever be the number. Now n plus 2 is 7.
Seven C1 plus 7C2 plus 7C3.
Consecutive terms. 7C1 plus 7C2 plus 7C3, right? So what do you get? Next step is 7 plus so third term will be 7 into 6 into 5 divided by 6, 35. So this adds up to 63, right? That's all. The answer is given. Options are given. So 63 is your answer. Okay. Okay. What about any other problem that we want to talk now? Or what we can do now? I think many students have gone. I don't know for whatever reasons. Keshav.
Yes, sir.
Or we can even schedule another class. Okay.
Yeah, yes,
So
sir.
this
That's
is-
சொல்லுங்க ராதா.
And the பழைய ப்ராப்ளம்ஸ்லாம் நிறைய போட்டுட்டே வரல. அதை நம்ம டிஸ்கஸ் பண்ணலாம் அப்படின்னு வச்சா யாருமே இல்லை எக்ஸப்ட் சுந்தரேஷன்.
நெக்ஸ்ட் கிளாஸ்ல வேணா அதை பார்த்துக்கலாம் அப்போ.
அது இன்னொரு வேணா நெக்ஸ்ட் கிளாஸ்ல வேணாலும் பார்க்கலாம், இல்லை இன்னொரு செஷன் வேணாலும். சரி, நெக்ஸ்ட் கிளாஸ்ல வேணாலும் பார்த்துக்கலாம். இன்னொரு கிளாஸுக்கு டைமே இருக்க மாட்டேங்குது.
ஆமா.
So next class, whatever problems, when more people are there, time ஆயிடுச்சு அதனாலதான். So we will discuss in the next class this and some of the practice problems in the in whatever we discussed today. Matrices also, matrices and determinants.
Correct.
Okay, so that we will do next.
Yeah.
Okay.
Okay.
Okay then.
Okay.
Yeah. யார் பொன்கனின்னு ஒருத்தவங்க இப்ப சேர்ந்துருக்காங்க.
இல்ல நான் இங்க இருக்கிறனால அவங்களை அலோவ் பண்ணேன். பட் அது ஒன்றும் யூஸ் இல்லை. லாஸ்ட் மினிட்ல சேர்ந்து என்ன பிரயோஜனம்? ஒரு 10 நிமிஷத்துக்கு அப்புறம் வரவே வராதீங்க. இட்ஸ் ஆஃப் நோ யூஸ் டு யூ. ஒரு 5 மினிட்ஸ்க்குள்ள 7:05 வந்தாதான் உங்களுக்கு யூஸ் ஆகும். அதுக்கப்புறம் வந்து பிரயோஜனம் இருக்கு. ஓகே ராதா, தேங்க்யூ.
Okay, yeah, thank you all. Hey, one sec. Keshav. Next Tuesday and Wednesday we are not in town, yeah. So
okay, we will reschedule.
I will talk to you. We will reschedule to